Welcome to Study Loop.
Okay, in this question, there's many parts, so we want to get first the lowest possible energy for electron and hydrogen. If we know its orbital angular momentum is the square root of 12 h bar, so we can set that equal, we can solve for little l, so we can say that that's l times l plus 1. And then if you solve for this, you can probably just see that it's if l has an integer, it has to be 3. So that would be L equals 3, and we want to get the lowest energy. So if L equals 3, then N has to be equal to 4 or bigger. So let's go with 4 because they want the lowest energy. And so if we want it in electron volts, then what we want to do is use our good old formula from the previous chapter, which is the energy, gives the energy spectrum for hydrogen. So it's minus 13.6 divided by n squared. So that's going to be minus 13.6 divided by 16. And that's negative 0.85. What a nice number. EV. So that's for A. I'll try to mark all these because there's so many parts to this question. Curious to see how it comes together. And then we want the small and large values of the orbital angular momentum. So we know that LZ goes from, so it's going to be ML times H bar, and ML goes from minus L to L. So we can say strictly the lowest would be minus 3 H bar. Did it say lowest? Oops, did it say lowest magnitude or lowest value? Let's go back and recheck the question. They said value, so I think it's going to be magnitude. So let's just think about magnitude. So the magnitude of LZ, this max is going to be 3H bar, and then the min LZ is going to be 0 because 0 is allowed. So that'd be 0 H bar. And it depends on what is interpreted by value. I would say that this is how I would interpret it, but the question might mean minus 3H bar. I'm not really sure. Yeah. So the next one is small, large values, spin angular momentum for the electron in part A. And so it's going to be this. It's going to be the same actually, because it's an electron that entirely determines its spin. So spin is going to be the square root of 3 over 2 times h bar. And for D, we want large, small value, angular momentum, electron in the M shell. I am going to pause the video while I look up how far the M shell is up. M is n equal 3. And so down, I should use a lowercase n. So we can say little n is equal to 3. And then again, I'm going to reread the question. Large, small values, orbital. Okay, so then that means the max L is equal to 2. And then I would say the max would be the square root of L times L plus 1, so the square root of 6 H bar. And then the min would either be minus this or 0 H bar.